Alright, section 10.3 and 10.5. These are the area of the regular polygons. So we're not just doing squares and rectangles and triangles and trapezoids and that sort of thing. We're going to have pentagons and hexagons and octagons and that sort of thing as well. Something to remember here, a regular polygon means that all sides are congruent. Okay, we won't be doing any pentagons that have different size sides. They're all going to have, all 5 sides are going to be the same. So, some useful formulas here. The sum of the interior angles of a regular polygon. So you're talking all of the angles around the inside of the shape on the outside of the shape though. So this would be n minus 2 times 180, n being the number of sides. We've done this before, so this should not be new. And then if you want to find the measure of one interior angle, you take the sum and then divide by the number of sides, and that would give you one angle on the outside of the pentagon or hexagon or whatever we're doing. Alright, some helpful hints here. With any regular polygon, you can circumscribe a circle about it, around it. So any regular polygon, a pentagon, whatever, you can draw a circle that touches all of the vertices of the shape. So every single vertex all the way around the shape is going to be on the circle. The center of the regular polygon is the center of that circle. So then you have radiuses in this, and it would go from the center to the vertex of the shape, because the vertex of the shape is also on the circle. So if you had a triangle inside a circle, the radius would go from the center to one of the 3 vertices. And then we have a new word that we're going to throw into this, the apothem. This is a perpendicular distance from the center to any side of the shape. Think of it as a height. It's kind of like the height of the shape. Okay, so a picture of this. This hexagon that I drew has a circle that goes around it. Notice it touches all the vertices all the way around. This red line that goes straight down is called the apothem, and we'll mark it with an A. Okay, usually we use A for apothem. Alright, and then all of these blue lines all the way around are radii, because they go from the center to the circle. But now we're going from the center to a vertex that is on the circle. So they're still radiuses, just a little different scenario. Okay, and it just so happens all of these triangles inside the shape are all congruent. They're all the same thing. And they're all isosceles. So if we go to try to find the area of each triangle, if we want to find the area of all of them, then we'd use the apothem as the height, and then we'd do the area like normal. And then we can multiply it by how many triangles were inside the shape, and that would give us the area of the shape. But there's a formula for this one, just like all the others. Alright, just a little exercise to get us started. It's a pentagon. So a pentagon has 5 sides, right? What is going on here? Alright, sorry about that. So pentagon has 5 sides. So let's start with angle 1, and we'll go from there. So angle 1 is inside the middle. So if you remember, in the middle, all of the angles have to add up to 360. So we take 360 divided by 5, and that gives us the measure of angle 1. Alright, so 360 divided by 5 gives us 72 degrees. So angle 1 is 72 degrees. Alright, for angle 2, what happens when we draw this height down? We said these were isosceles triangles. So when we draw this height down, it actually splits the angle here in half and creates angle 2. So angle 2 is actually half of 72. So it's 36 degrees. And then angle 3, we have a right triangle. We have a 90 in here. We know angle 2 is 36. We need to find angle 3, and you know your triangle has to add up to 180. So if we do 180 minus 90 minus 36, that gives us angle 3, and that would be 54 degrees. Okay, and you have to use this periodically to help find the area. We may have to do some SOHCAHTOA or something like that. All right, the formula you need to remember for this, and I have two versions of this formula. You have version 1 and you have version 2. Okay? It says the area of a regular polygon is half the product of the apothem and the perimeter. So that's this formula, number 2. Okay? A is the apothem, so we'll label that. And then P is the perimeter of the shape. And we know perimeter is the distance around the outside of the shape. So you take whatever the apothem is times whatever the perimeter is, that would give us our area. Okay, now the first formula is actually broken down a little more, and it's sometimes a little more useful this way. Okay, N is the number of sides. A is still your apothem, so I'll just draw an arrow over to that. S is the length of a side. So if you remember, to get the perimeter of one of these shapes, if you just take the length of a side times the number of sides, you get the perimeter. So that's why these two formulas are exactly the same thing. We're only going to use one or the other. It depends on what we have. We could use the 1/2 AP all the time if we wanted to. Okay, so let's go try this out. All right. So we have, it says find the area of a regular decagon. Decagons have 10 sides. It says it has a 12.3 inch apothem and 8 inch sides. So if we were to do the 1/2 N times A times S formula, I just rearranged it a little bit. That means we need to know what N is, we need to know what A is, and we need to know what S is, and then we can just plug and chug. Okay? N is the number of sides. That's 10 because it's a decagon. A is apothem. They tell us this. So we're going to put in 12.3. And then they tell us that it has 8 inch sides. So S is 8. So we just need to plug all of this into our formula and hit go. Okay, plugged everything in. Now we need to plug it into our calculator. So 1/2 times 10 times 12.3 times 8. We get 492, and then our units were inches, so we'll do inches squared. Okay, not too different yet. It's still a formula. You still have to plug everything into the formula and make sure everything's right. Okay, gonna be a little more work involved with these at some point. Alright, so let's do the same thing. Let's do the N, A, and S, and let's see where we get. So, N is number of sides. It says find the area of a regular pentagon. So number of sides would be 5. The apothem, they tell us, is 8. And then the side length is 11.6. So we do 1/2 times N times A times S. And we're going to type that all in our calculator. So 1/2 times 5 times 8 times 11.6 be 232 centimeters squared. Okay? So right now it's just a plug and chug kind of thing. When we get to section 5, there's a little more work involved. Okay? Alright. So now we have a regular hexagon. They gave us a picture this time instead of words. So hexagon has 6 sides. So N equals 6. I need to know my apothem. That's a problem, isn't it? Because we don't have it this time. But they tell us some angles here, and that's kind of helpful. You look at this triangle that has the 30 degrees in it. That's a 30, 60, 90 triangle. So remember, smallest side is opposite the 30, so then opposite the 60 is smallest side times √3. So the apothem is 5 √3. And then the side length, they give us is right here. So it's 10. So we do 1/2 times the number of sides times the apothem times the length of a side. And we're going to type all that in, and you can leave it in radical form or you can change it over to decimals. It'll do the same thing. If we were to leave it in radical form, it'd be 150 square root 3. If I change that to a decimal, I get 259.8, and it would be millimeters squared. Okay? Changes the game a little bit when you have to start finding these. That 30, 60, 90 triangle is coming back with a vengeance. Alright, one more and then we're going to go over and do some trig. The side of a regular hexagon is 16 feet, and it says to find the area of the hexagon. So maybe we need to draw a hexagon. Let's draw one first, and then we'll go from there. Okay, it says the side is 16 feet. So that means all of its sides are 16 feet. So, think of all these triangles that are in the middle of this shape. Okay, we just had a hexagon. They told us that one of these angles in here was 60 degrees. And if you're not sure why that is, remember all of these angles in the middle have to add up to 360, and there's 6 of them. So you take 360 divided by 6, you get 60 degrees. Okay, but we need the apothem right here. So that splits that 60 in half, makes this a 30. So now we have a 30, 60, 90 triangle. The side was originally 16 because all the sides are 16. But when we draw the apothem down, this becomes an 8. So then to find the apothem, it's across from the 60. So it would be 8 square root 3. Okay? So number of sides is 6 because it's a hexagon. The apothem we found to be 8 root 3. And the side length is 16. So we do 1/2 times 6 times 8 root 3 times 16. Okay? And we can leave this in radical form first if we want. So that would be 384 root 3. If we want to change it to decimals, we just hit the button on our calculator and we get 665.1 feet squared. Okay? Now, the game changes a little bit when we go over here to section 5. It's still regular polygons, but now you see this word. So SOHCAHTOA just came back. Okay? So let's start. Baby steps. So first we're going to find an area of a square. We know squares have right angles all the way around, right? So when I draw this apothem down, think about how this gets split. It splits from every corner. There's 4 angles in here, and it's a rhombus. So you know these are right angles. So when we draw this apothem down, that makes this a 45. That makes this one a 45. So that's a 45, 45, 90 triangle. So technically, this apothem here would be the same length as this piece down here. Okay, so we could do Pythagorean theorem to find those A's that we need. Okay, so let's do a little Pythagorean theorem here. Alright, so we get A, if you take the square root of both sides, is 2 root 2. So this is 2 root 2, and this is 2 root 2. Okay, so if we're going to do the formula like we did before, we need these 3 things. Number of sides would be 4 because it's a square. Apothem is 2 root 2 because we found it. The length of a side is this entire thing. Half of it is 2 root 2. So the whole thing is 4 root 2. Now we just need to plug it into the formula. So we'll do 1/2 times number of sides times the apothem times the length of a side, and we'll hit go. Okay? So 1/2 times 4 times 2 root 2 times 4 root 2, and we get 32 yards squared. Now that's not the only way that you can do this one. There are other ways to do a square, and so if you find another way, that's awesome. You just have to get 32 whenever you get done. Okay? Just another shape that we can show you. Alright. Hopefully you remember this. Remember SOHCAHTOA. SOHCAHTOA. Remember that one from January? It's been a while. So, this is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay? You're going to need this with any shapes that are not a hexagon or a triangle or a square. Everything else is going to need SOHCAHTOA. Okay? So if I say sine of A, we're just going to look at angle A. Sine of A is opposite over hypotenuse. So A is the opposite. C is the hypotenuse. So this would be A over C. Cosine of A is adjacent over hypotenuse. So that would be B over C. And then tangent A is opposite over adjacent. So that's A over B. Hopefully you remember this because you need to remember how to set these up and solve for them. Alright? Some more review. Remember, if you're finding A, the angle, you're finding the angle, this is the one that you hit second cosine in your calculator, so it looks like cosine to the -1. And when you do that, you do second cosine 3 divided by 4. Angle A is 41.4 degrees, just in case we need to remember how to do this. Alright, down here it's a little different. You're not finding the angle, so you just hit cosine 34. You get 0.829 equals x over 4. And then because we're really good at algebra, we say, oh, well, we're going to divide both, or multiply both sides by 4 and get x equals 3.3. Okay, hopefully all this trig stuff is cemented in your brain enough that you can get it back. Alright, so let's go use it. Now we've got a pentagon, so I could draw you a pentagon if you want. If you need a pentagon. Really all we need is the triangle inside the pentagon, but it's okay. And here's all of its triangles. And it tells you that it has 8 centimeter sides. So all 5 sides are 8 centimeters. So n is 5. Let me make that better. N is 5. The apothem we don't know yet. The length of a side is 8 because they told us. Okay, so if we draw the apothem right here, that splits that 8 in half, makes this 4 and 4, right? We need an angle in here. Okay, so we started with 5 angles in the middle. So we take 360 divided by 5, we get 72. So each of these angles in here is 72 degrees, the big purple angles. But when we draw the apothem down, it splits in half, makes it 36 degrees. Okay, so if we redrew this right triangle so we could kind of focus on it a little better, it's got a bottom of 4, it's got an angle of 36, and this is our apothem that we need to find, that right there. Okay, that is trig. So if we look at this, we don't have the hypotenuse, so that's tangent. Tangent 36 equals opposite over adjacent. Here we go again, right? So we do tangent 36 first. We get 0.727 equals 4 over A. And this was the one where we multiplied both sides by A, and got something that looks like this. So you're actually taking 4 divided by 0.727. That gives me an apothem of 5.5. Okay? Now, if this doesn't make sense, you're going to have to ask for help. Alright, so we plug everything into the formula. 1/2 times n times a times s. So 1/2 times n times a times s. We get 110 centimeters squared. The process just got a little bit trickier, didn't it? Okay, so let's go try another one and make sure that we've got this under control. Alright, this time it says it's an octagon. Now I don't know about you guys, but my drawing skills for an octagon are pretty bad if I don't have this tool. So here's my octagon. Okay. But how much of the octagon do you really need? You really only need the triangle that is created after you draw all these radii, right? You draw all these in, creates all the isosceles triangles, and then you draw the apothem down. That's the triangle here. Okay, so this is A. We need to find what this is, and then we need to find the angle in here, and we'll be good to go. Okay, now it tells us that it has a perimeter of 80. An octagon has 8 sides that are all the same length. So if all the sides are the same length, we could just take 80 divided by 8. That tells us that one of these sides is 10. Automatically. Because if you did 10 plus 10 plus 10 8 times, you're going to get 80 out of it. But when we draw this apothem down, that splits that 10 in half and makes this 5. Okay? So we're going to put 10 in for S, but it's 5 in our triangle that we need to find. Okay? Now, we need angles in here. There's 8 angles around the middle of an octagon. So if you take 360 divided by 8, you get 45 for one of these angles. But we drew the apothem. So that splits that 45 in half, makes this angle right here 22.5. Okay, so now we have our right triangle. There's no hypotenuse, so that's tangent. So we do tangent 22.5 equals opposite over adjacent. And you're going to solve it just like the last one. You're going to do tangent 22.5 and get 0.414 equals 5 over a. Last time we multiplied by a to both sides, got 0.414a equals 5. So you're going to take 5 divided by 0.414, and we're going to get 12.1 for our apothem. So now we can plug everything into our formula. Alright, so we're going to do 1/2 times 8 times 12.1 times 10. And we get 484 inches squared. Okay? Just a little bit more work. Sometimes you have to find the side length too. Just depends on what they give us. They might give us the radius. So then we would have a hypotenuse. So then we'll have to use that. Okay? Just be prepared. Alright. Another thing that kind of pops up. What happens if you have a triangle that you don't have a height for? Sometimes we can find a height if we want, but we don't always know. So this is the area of a triangle given side, angle, side. So they have to give us a side and an angle and a side, just like when we did congruent triangles before. So if they do that, you can literally just plug this into the formula and hit go. Okay? 1/2 times whatever the side B is times whatever the side C is times the sine of angle A. And hit go instead of finding the height and all that business. Okay, so let's go try this. So triangular land plot, they gave us a side and an angle and a side. So we do 1/2 times one side times the other side times the sine of the angle. and you should be able to type this all in at once and hit go. So I did 1/2 times 412 times 386 times sine of 71, and I get 75,183.9 square feet. Okay? These problems are that easy. Don't overthink them. They're going to give you exactly what you need to know. Alright, let's try another one. They tell you two sides of a triangular building plot are 120 feet and 85 feet long. They include an angle of 85 degrees. So this would be 1/2 times 120 times 85 times sine of 85. And we type this all in our calculator all at once. And when you do that, you get 5,080.6 feet squared. Okay, just a little anomaly that comes along. You can still do triangles the same way, but you would have to find the height and all of that stuff. Alright, good luck!